Good afternoon, sir.
Hello, Subhitsha. So last session we did this problem. Okay, so the second part, did you try the second part of this question?
Yes, sir.
Did you get it?
Yes, sir.
Okay. Now I think now you can understand these things, right? After doing these things.
Yes, sir.
Okay, so next 25,
28th question.
28th question. Okay. A and B is easy, but find A is easy, but B and C is very complicated. Uh, find the charges on beta and gamma. B is also easy. Find the velocity of the plate after the collision and at a distance t from the plate B. Two fixed identical conducting plates alpha and beta minus Q. P to move is located on the other side of the plate with charge plus Q at a distance t. As shown in figure, the third plate is released and collides with plate beta. Assume the collision is elastic and the time of collision is sufficient to redistribute charges amongst beta. Okay, I'll just show you. Did you see the solution here? Solution of this problem? Like you must have been just not that difficult to understand. First two parts are not that difficult to understand. Let's stick it here. Okay, just check out the first solution and tell me what did you not understand here. Here, let me just tell you this thing that they have used this S. S is the surface area.
Yes, sir, but what formula have they used to here for this?
Okay. Do you remember that thing, that sheet and plate? I told you the difference between sheet and plate. This is surface area. And when I talk about something like this is a sheet and this is a plate. Okay.
Yes.
So when we talk about sheet, then here at any point P, what is the electric field? You remember you have just do you know the formula? I have given you the formula to these things, sheet and plate. I said that you have to draw a cylindrical Gaussian surface, both the sides. Do you remember this formula? Electric field is equal to sigma by epsilon naught.
Yes, sir.
Is the thing. And for the plate, at any point P, this is electric field is equal to sigma by 2 epsilon naught. Or am I mistaken? Just a second.
Sir, but isn't sheet sigma by 2 epsilon?
Sorry, what?
So isn't sheet sigma by 2 epsilon naught?
Oh, sheet 2 sigma, right? Sigma by 2 epsilon naught, and this is sigma by epsilon naught, right?
Yes, sir.
Um, just confirm. Yeah, that's correct. Conducting plate. Here we go. Yeah, correct. This is this thing, sigma by epsilon naught, sigma by 2 epsilon naught. And here, two fixed identical conducting plates, alpha and beta, each of surface area S, are charged to minus Q and Q respectively, where Q is greater than small q is greater than 0. 0 is less than Q. Okay. Okay. And they have used the electric field at gamma due to alpha is okay. What they are doing actually, they are treating just one surface of the plate. They are treating it like sheet. They are very, very thin. They haven't mentioned it properly, but yeah. Um,
So, but in the question, they've given plate, but then the formula they've used the formula sheet.
yes, that's the problem. That's the terminology difference. Why
So,
are they
when should we
doing?
use which formula?
Yeah, that's the confusion. They should not be using this kind of terms. Hmm.
So, because in the solution I have also they use the same formula.
Okay. NCERT book doesn't say anything about these things, right? Anyway, they are just treating this thing as sheet, right? That is the thing.
Yes.
That's the terminology difference here. Forget about this thing here at this point of time. And plate, just see that actually one limitation was there. Even when we are talking about plate, when we say that plate, then the plate is never separated something like this. A plate is never single. It doesn't stand alone. It always comes with another plate. Like in capacitor, we'll talk about capacitor. Like if this is positive, if this is positive, mm, sheet, right? One side of it. Two fixed identical conducting plates have a measure each of surfaces minus q respectively over third plate. Um, it's not talking about the other side, one side of the plate. Okay, I think they are using the fact this one. Leave it. Like when you're talking about this plain plate, then there are two sides of it. If charge is uniformly distributed, this side, and the other side is also uniformly distributed, right? Same charge. If there is plus Q charge over here, plus Q charge will be here also. That is the thing. Because if this is a conducting plate, then the charge should be uniformly distributed throughout, right? That's what happens.
Yes,
There
sir.
is a small thickness here. So what they are treating, I think they are treating just one side of the plate.
Okay.
One side of the plate will behave like a sheet, right? One side of the plate,
Yes.
one side of the plate behaves like sheet. behaves like sheet. That is what they are using here. So now it is very, very easy because a sheet produces a uniform field near it. So now it is very, very easy for you to understand now. Sigma is equal to what? Sigma is equal to simply Q by S. That's what they are using, right? Q by
Yes, sir,
S.
that's what I understand.
Yeah. So
I
electric field,
asked net electric field, I don't get it.
which one?
The net electric field, I don't get why it's capital Q minus small q and not small
Okay.
q minus capital Q.
Okay, okay, okay. Just see this. Okay, that is, oh, see, this thing you understood? You agree with this thing, right? Minus Q is a negative thing. So field here due to plus Q, this will be this side, right? This is E1 and field due to this thing will be on this side, E2. Tell me what is E1 in this case? This is actually E1. This is actually E1, right? E1,
Yes, sir.
E1, E1 vector, and this is E2 vector. This sign, just see the X cap is what? The horizontal direction. X cap means unit vector along horizontal.
Oh, okay.
Along the horizontal. So E1 vector is clearly opposite, right? A horizontal direction. So this is the X direction. This is the plus X direction, X cap direction. This is minus X cap direction.
Yes, sir.
So E1 is directed in which direction? You see that minus X cap direction, right? This X is given to
Yes,
you.
sir. So that's why it's negative.
That's why it's negative. And this is in the positive direction. So this is positive. So now just see this thing. If you add this thing, so net electric field will be equal to what? Okay, I'm using E1, right? So okay, they are terminology difference. You can understand this. I'm just using these things, right? Just see that. Let's say that EA, EB, something like this. So E1 will be equal to what? E1 EA plus EB. Very simple. So this will be what? Um. Okay, let us just
Small
say
q.
that E1 will be equal to usual method. Let us just say that EA plus EB. EA plus EB vector, right? Okay. So this is minus Q by S2 epsilon naught X cap plus Q by S2 epsilon naught X cap. This will be the thing. And now if you take this thing, um, okay, minus Q plus Q by S2 epsilon naught X cap. That is quite acceptable answer. There is no problem with this thing. It is the same thing as this one. Just see that. Just take out the minus sign common. This Q minus Q by S 2 epsilon naught S, right? This is the thing.
So, but why do we need to do this?
No need to do. You can skip here. This is acceptable. You can just stop
Yeah.
here. No problem with that thing. But what they are with this expression, they are just ensuring that the magnitude is equal to plus Q to epsilon naught S. This is the magnitude, and the direction is in the negative X direction. That's what they are showing. Direction of the vector is in the negative X direction. That's it. This is a positive quantity because Q is greater than small q, capital Q is greater than small q. So this term is coming out to be positive, and the direction is in the negative X direction. That's what they are mentioning over here. That's it. Nothing else.
Yes, sir.
Right? Okay, this is done. Um, B. Now this one, let's just see how they have done it. During the collision, plates beta and gamma are together and hence must be one potential. Okay, this is a potential question. We'll do it later, but okay, let's just discuss it a little bit. We should do this problem later on when we'll talk about the potential from what is the potential, why the potential needs to be same. Then you'll understand this one. But let's just take it for granted for now. Whenever two charged bodies, let's just see that what it means. Like let us say that there is a body, this is plus q charge, and there is another identical body, this is plus q charge, small q charge. If you bring them in contact with each other, what will happen? Let us say that this is greater than this one. Charge will flow from one body to another body because they are conducting plates, the conducting bodies. So how long this conduction of charge will take place? Unless unless and until the potential of both the bodies become the same, not the charge becomes the same, right? Because they may be of different shapes or sizes. If they have the identical shape, then you can easily see. But just see this thing. If this is this big, this is this big, and if this is this big, and this is having plus q charge, this is having plus q charge. If you connect them together, how long the conduction? Let us say that capital Q is greater than small q, then the charge will flow from electron will go from this side to this side because it will try to attain. It will not try to equate the charge. It will try to attain the same potential. When the same potential is attained, there is no electric field inside the bodies, and in that case all the free electrons will remain stationary. In that case there will be no
Okay.
forces acting on it. So the force on the free electrons will be acting for as long as there is a potential difference between them. That's why, so the current will flow unless flow for as long as there is a potential difference. The moment the potential becomes equal, there is no current. Free electrons will stay at the same position after that. So that's what happens here. So during during the collision, plates beta and gamma are together and hence must be at one potential, they are saying. Must be at one potential. Suppose the charges on beta is Q1 and okay, so it has been given over here. So beta is Q1 and gamma is Q2, and consider a point O here. The electric field here must be zero here. Electric field at O due to alpha is this one, right? Negative x direction due to alpha is negative x direction, correct? And due to gamma is okay. Due to gamma is due to gamma is also in the negative direction, correct? Negative x direction, and Q1 is positive x direction, correct? Due to beta, alpha would be in this negative x direction, that is correct. Beta should be okay. This is wrong, right? This is wrong, a little bit wrong here. It is negative sign is given, it should be positive. That is wrong. One mistake here. Because beta, just see that beta is here. Here, Q1 is a positive charge, right? So it will produce an electric field in this direction. Definitely. Q2 is also positive, so it will produce an electric field in this direction. If I say that E1, this is E2, clearly, right? Opposite direction. I'm calling this thing as E1 and calling this thing as, sorry, this thing as E2. So E2 is in negative x direction, you can clearly see this thing, and E1 is in positive x direction. So this negative sign is wrong here. And then if you take the sum, you will get this one. And then you can solve it and you'll get the charges.
So could you please explain this question?
Okay. I'm saying, let's say that
I
it
think
is
I said I don't understand the diagram they've given here.
Okay, you didn't understand the diagram. Okay, fine. Just see here, this is here, beta and gamma. So there is some
Yes,
where this is alpha, right? This is alpha.
yes, sir.
So what is the electric field here due to at O? We are just considering they are now, when they collide with each other, they are joined together. That's what happens
Direct
here.
zero.
Yeah. So we are considering a point inside this plate. And since I have told you, okay, we haven't done this thing. This is the subject matter of the second chapter. Inside the conductor, electric field is always zero, no matter what happens. Inside the conductor, electric field is always zero. I think I've told you, right? Inside, no matter what
Yes,
happens, shielding effect, right? It has already been said that they are conducting plates. They are conducting plates. It has
so
been
but for
given here.
alpha will be zero, right?
What?
So then alpha also be zero, right?
Uh, which one? I saw. Sorry, I didn't. Oh, your audio is not coming clear today. Is there any problem? The audio is breaking, actually.
So then alpha should also be zero, right?
No,
Since
no, no.
that
Alpha is not zero. Just see that. What happens? I said that net electric field will be zero, right? Not the field due to alpha, beta, or gamma. Net electric field at O will be zero due to everything. It will rearrange itself in such a way, right? Charges rearrange itself in the presence of external electric field so that the net electric field inside the conductor is always comes out to be zero. Inside the conductor, if I place a positive charge here, then also the electric field, then more electrons will come here, this side. But why do they come on this side? Why the induction of negative charges is placed? Because it tries to maintain zero electric field inside. That is the thing. So there are so many things that could happen outside, but inside the electric field will always be zero. That is the thing. Okay, let us see this. Alpha, beta, gamma. Now you understand that the field here, net electric field is definitely zero, right? We know that.
so
Electric field is zero. But this is the net electric field, not the individual electric field. This electric field is the sum of all the electric fields due to all the sources around. There are only three sources, alpha, beta, and gamma, which are producing the electric field. So sum of these three fields should be zero. Sum up to zero. So let us just see this thing. We will calculate this
of
thing.
course alpha, beta, and gamma should be zero.
Yes.
So why not only beta and gamma? Because only beta and gamma are colliding.
No, because this is also setting up the electric field, right? Alpha is also there. We have to consider everything around that point because
Okay.
field can go inside also, right? This is the thing. This is E alpha. Let us say that this is E beta, and this is E gamma. Sorry, this is E gamma. E gamma. So there is only one mistake in this problem. This should be positive. Okay. Direction. Just tell me. You tell me what will be the direction, right? At O, what is the direction of E alpha? Towards it or away from it? This is having what charge? Minus Q charge, right? Minus Q charge.
Yes, sir.
So electric field
So
at O.
alpha means electric field or from alpha.
Hmm. Electric field due to alpha at O will be in which direction? Superposition principle will use. Imagine that there is only alpha and there is no beta and
Away
gamma.
from
No, it
towards.
is negative. It is negative charge, right? So if I
Yes, sir.
imagine a plus 1 coulomb of charge at O, this will be attracted towards this.
So, but won't electric field lines be from positive to negative?
Positive? No, no, no. Last class I cleared this doubt, right? That whenever you're trying to find out the direction of electric field, you always imagine the +1 coulomb of charge at that point, imaginary +1 coulomb of charge. And
Yes, sir.
then,
So, towards the left.
yeah, then it is left, right? It is left.
Yes.
It is left, right? Okay, so this
Yes.
is E alpha. So tell me now, what is E beta? E beta will be in which direction? Now Q1 is positive, Q2 is also positive. And you may ask
Towards the
like
right.
what,
Towards the
right, right?
right.
See, why Q1 and Q2 needs to be positive? Because initially they were positive, right? So when they collide, the same redistribution of charge will take place, but they will still remain, the net charge will still remain the same. Yes. So beta will be in the right direction and gamma will be in what direction? Gamma will be in the left direction. So you added, just see this thing. Now net electric field will be equal to what? E alpha plus E beta plus E gamma should be equal to 0. That's it.
Yes,
That's
sir.
what they have done. Right? This is the case. And if you do so, you will get this equation, and that's it.
So after you explain, I understand like how to do it, but in case they just give this, how will I be able to solve on my own?
Usually just see this thing. Whenever you get this kind of plate questions, then imagine they are giving it only, they are just considering one face of it, right? Not the entire plate. If you consider the entire plate, then the field will be this thing I told you, sigma by epsilon naught,
Yeah.
right? Sigma by epsilon naught. But if you're just considering one face of it, then you'll always take this. Most of the time, you'll be using this equation, sheet, because whenever you're dealing with these kind of problems, they just mean that one face of it. Charges distributed over one face of it, so that will be simply a sheet, an infinite sheet.
Okay.
And whenever you're solving this kind of question, always apply all the concepts that we have talked about, right? Make sure that the direction of electric fields you have chosen correct. And like this, there is a mistake, right? NCERT is not always perfect. There are some mistakes here in NCERT solutions also sometimes. Like here they have given is negative sign, and you will try to find it. Okay, NCERT can never be wrong. What is the explanation of this negative sign? No, with your concept, does it? You cannot explain this negative sign, right? You cannot explain
Yes,
this
sir.
negative sign. There is no explanation for this negative sign. So what does your concept, your understanding says? Negative sign doesn't make any sense. This should be positive. Otherwise, this question cannot be solved. There are some printing mistakes, right? Maybe they know it, but there are some printing mistakes. Because of that thing, this kind of things happens. So make sure that whatever tricks or whatever concepts I've given you, just use those concepts. How to find out the direction of electric fields, just add them. This is a superposition principle, right? Indirectly, you are using the superposition principle. And everything, whatever we have done, if something is not falling into place according to what we have already learned, then I think you should not attempt that question, right? That is dangerous. You're going into the danger zone. Okay, this one is done. Clear? Now I think you can understand this one.
Yes, sir.
Okay, now here, this part is a bit complicated. Let me see how they have done it. Let the velocity be, what's the question? Find the velocity of the plate gamma after the collision and at a distance d from the plate beta. Q. Let the velocity be v at a distance d after the collision. If m is the mass of the plate, then the gain. Okay, this is the concept that we'll talk about after we are done with the second chapter, because here the kinetic energy concepts are involved, right? Let it be. Then only you'll understand, because then we'll talk about what do we mean by kinetic energy, why it needs to be constant, where is it coming from. So let it be this solution for this time being. Once we are done with the second chapter, then we can come back and discuss this question.
Okay.
Next question is what?
So 29th question.
29. You haven't sent me the 29th question. Okay, let me just get it from the book. I have the book, no problem.
Okay.
I'll just. There is another useful unit. Okay, unit question, right? This we can. Okay, let it be. 29, this is a unit question. We'll deal with it later. 30th question, let's do it. This one, right?
Yes, sir.
Plus, and solution is also given, but I hope you didn't understand any of it, right? Solution.
No, sir.
Uh, did we discuss simple harmonic motion in 11? Did we do the simple harmonic motion?
Yes, sir.
We did? Okay.
Yes, sir.
So tell me, what did you find difficult here? What is it that you're not getting?
So they've taken cos theta and all. I'm not sure like how they're taking it. Like why they've
Okay.
taken cos theta here.
Okay. Here two charges minus q, each are fixed separated by distance 2d. A third charge q of mass m placed at the midpoint is this. Okay, tell me, this is the midpoint, right? What is the electric field here? Tell me. Can you tell me? What is the electric field here? Just imagine that there are only two charges.
K minus q by d square plus k minus q by d square.
Minus q? Oh no. From the symmetry, it should be very obvious to you that it should be zero.
0.
Definitely.
Should be
Right?
minus, sorry,
Yeah.
because it's in opposite direction.
They are opposite directions, right? From symmetry, they are equidistant and they have the same charges. So E should be zero, right? It's very simple.
Yes, sir.
Electric field is here zero. So it means if I place a Q charge over here, what will happen to Q? It will stay at the same position, right? There will be no force. What will be the force acting on this thing? This is Q times E. That is zero force. It means that is the equilibrium state. It means this is the mean position. Okay. If that is the mean position here, okay, let me see other questions. A third charge Q of mass M placed at the midpoint is displaced slightly by x. X is much less than D, perpendicular to the line joining the two fixed charged, uh, as shown in figure 1.14, show that Q will perform simple harmonic oscillation of time period. Okay, this thing. So you need to find out the net force acting on the charge when it is displaced from it. Here we know it for sure that if the charge is at the mean position, the net force is zero. What is the force? Uh, for the spring force, you know this thing. If this is the mean position of this thing, if the spring is stretched like this, tell me what is the direction of a spring force here? If x is equal to 0 here, force is what? Force will be acting in what direction? Compare it with the spring force. You'll understand it.
It'll be towards the left.
Towards the left, correct. So force will be in this direction because force is always equal to minus kx. If any motion can be described with the force F is equal to minus kx, then that motion is simple harmonic motion. Very simple. That is the definition of the simple harmonic motion. So here we just have to prove that force is directly proportional to the displacement. Once we do that, it is proven that the motion of the body is simple harmonic motion. So we just need to show that the force, the net force acting on charge Q is directly proportional to the displacement. Okay. So how are we going to do that? Tell me minus Q, if the plus Q charge is here, minus Q will, you actually do this thing also. So here, this is the mean position. And just see that this plus Q will be pulled towards this direction by minus Q, right? And just see this thing. If this is F force, this will also be F force, isn't it? Because by symmetry, they are equidistant from each other. Clear? This thing? Tell me what is the net force acting on the body? If you resolve,
Yes, sir. Sir, I'm not able to see screen.
oh yeah, I don't know what happened on this. What is this? Okay, fine now, it's fine. Okay, so just see this thing. You will just see that. Do you agree that the force acting on? Can you tell me what is force F here? Given the magnitude of force.
So the force
Yes.
acting on
Plus Q. See, I said what? Minus Q, because minus Q's are on both the sides. Just think about this one minus Q charge. This will be attracting plus Q, and this minus Q will also be attracting this plus Q, right? Towards itself. So net force acting on plus Q will be in what direction? Oh, we'll figure it out. It will be definitely in the downward direction. My internet is unstable. Anyway, this is the thing. So can you tell me what is F? I said that both the forces will be exactly the same. Why? Because of symmetry. I can directly say that, right? Because Q is equidistant from minus Q on both the sides. Tell me what is F? What is this distance? This distance? Let us say that this distance be R. Let's say that this distance be R. What is R? First you tell me these things and then you'll already understand these things of what I'm talking about. This is R. What is R?
root d square plus x square.
Correct. Root x square plus d square. Right? What
Yes,
is
sir.
F?
K minus k q square by
Okay,
root
here you
x.
have to be careful, right? I told you during the calculation, because I have already shown the direction, no need to take the minus sign into consideration anymore,
Yes,
right?
sir.
So
K q
simple,
square by root x square plus d square.
correct. So R square is that thing, so K Q square by X square plus D square, right? You can say this thing, this is the force. That's it. And now just tell me, we need to figure it out that what is the net force acting in the downward direction. Tell me, if you resolve this force, let us just do it with a different color. There will be one in this direction, this will be F sine theta. There will be another F sine theta on this direction. And there will be one F cos theta and another F cos theta in this direction. F cos theta, F cos theta, isn't it? So you can see this thing, these forces will cancel out each other. Cancel out each other. So the net force acting on Q Q is equal to net force acting there, that's what I have taken. Okay, let's just use a different direction, different notation. Let us say that this F dash, F dash, F dash, F dash. Because F they are using it here, so I'm using a different F symbol. So F will be equal to what? 2F dash cos theta, isn't it? Simple. This is F dash, F dash. 2F dash cos theta will be the net force acting on this thing. Because F sin theta, sin theta are in the opposite directions, they will cancel out each other. There is no horizontal force
The x
on,
component cancelling out with the y components f
yeah,
cos theta and cos theta.
They are not cancelling out. So that is why the net force acting on this thing 2f dash cos theta, right? That is it. This is
Okay.
f dash is equal to what? Kq square is equal to this thing. And now cos theta is equal to what? Can you tell me? Cos theta is equal to what here? You yourself can figure it out. Cos theta is equal to,
X by R.
yeah. Cos theta is equal to b by h, right? So in this case, base is equal to what? X. And h is equal to what? Simply root over x square plus t square. That is the thing. Clear? This thing. So this is
Yes,
what
sir.
they have done, nothing else. Right here, f dash is equal to what? 2kq square x square plus d square cos theta is equal to what? X by root over x square plus d square. That is the thing. And now they have used a negative sign here because this force is always towards the mean position. Like this is the net force acting this, since the force is always towards the mean position. Since the force always towards the mean position, we can write f is equal to minus 2kq square by x square plus t square 3 by 2 x, right? This is what we can do. Now there is a condition given, x is much less than d. Since x is much less than d, what is the f now? Just reduce this thing. Minus 2kq square by d square x. Clearly f can be uh anyways, let us say that this is beta x, not using the k sign over here. So clearly f is directly proportional to x, simple harmonic motion.
Yes, sir.
Where beta is equal to okay, just see this thing. Where beta is equal to, here just see that they, why you get confused here, because they are directly using the k symbol as 1 by 4 pi epsilon naught, right? Don't do
Okay.
that. That confuses you a lot. I don't need to do that, right? I'll do it later. That's why the things becomes very complicated here. So don't put this thing, just keep it in mind that k is 1 by 4 pi epsilon naught, right? I'm not using that thing. So here beta is simply equal to what? 2k q square by d square. Sorry, d cube, right? D cube. My mistake. D square is cancel. This is d cube.
Oh, yes, sir.
This is d cube. So that is this thing. Now you know that there is one thing. What is this? F can be written as minus beta, sorry, beta x and um, MA minus beta X A is equal to minus beta by MX, and this thing is called omega square is equal to beta by M. So omega square can be equal to simply beta, just put this value over here, 2kq square d cube m power half. That is the thing. And omega is equal to 2 pi over t, 2kq square by d cube m to the power half. So t will be equal to what? Take the reciprocal of it. 2 pi d cube. What I'm doing. 2 pi, sorry. T by 2 pi is equal to 2kq square d cube m minus half. So T is simply equal to 2 pi 2kq square d cube m. This is the simplest form. You can just leave it here. No need to do this thing, right? Now you can put the value of k here, 1 by 4 pi epsilon naught, and then you'll get the same answer. Time period is equal to exactly this much.
Yes, sir.
Okay, they have used a different formula here, and that's not wrong. Root over k by m. So that's wrong. That's again wrong. Where is this omega coming from, right? This is wrong. Because omega itself is equal to 2 pi over t, right? This expression is a little bit wrong. This is the correct one. In fact, this is correct. Then omega is equal to simply 2 pi over t. Just put this thing and then you'll get the time period. The way I've done it, right? 2 pi by omega will not be there. Only 2 pi will be there.
Okay. Yes, sir.
Done?
Yes, sir.
Okay, so this question is done, right? In fact, any kind of simple harmonic problems can be solved like this. Simple, you have to show this thing that force is directly proportional to the displacement. Then that is the confirmation that it is a simple harmonic motion, and just find out
Okay.
the time period with this method only, because this is the thing that a must be equal to minus omega square x. Express the acceleration in this format, and omega square, then omega is equal to what? Simply 2 pi over t. Just use this concept to find out the time period. That's it.
Okay.
First, find out the force. First, you have to find out the force. Force in terms of minus kx, right? And then you will find out the formula for A, or very simple, you can directly say this thing that omega is equal to root over k by m. Omega is equal to this thing also, root over k by m.
Yes, sir.
So first, then you'll have to find out the k value. Now, why I'm not using k value here? Because k means 1 by 4 pi epsilon naught here, right? So use some different symbol for k. The next question is what?
The 31st question, the last question.
Okay, it is exactly the same. I think now you can do it yourself. But let's just discuss it.
Yes, sir, I'll try it now.
Yeah, it is exactly the same way. See, why they make it in their solutions, they do not give you the complete solution. There are some errors and there are something that needs to be figured out. Again, just see this thing here. It is exactly the same question. Instead of the two charged bodies, total charge is uniformly spread along the length of a ring of radius r. A small test charge plus q. Just see this thing. In this case, the net electric field will definitely be along this direction. Along this direction. Okay? Oh, no, no, no. My mistake. Minus plus q, right? Electric field will be in that direction. A small test charge plus q. If plus q is placed over here, just see that this will again experience the same kind of force from both the directions. This is one thing. This is one thing. And in this case, it will be experiencing the forces from all the cuts, vertically opposite points. And net electric field will be directly downward, right? So if Q is placed over here, simply net electric field here will be what? At the center is net electric field is equal to, by symmetry, it is zero. It is definitely zero. So force here will be zero. The moment you try to take it, displace it along this direction, then a net downward force will come into play and it will try to bring it back. In fact, just see that the body will be at equilibrium, and this equilibrium is a stable equilibrium. If you slightly disturb it, it will again try to come back to its original position, and by inertia, it will keep on moving in the forward direction, and the simple harmonic motion will happen. That is what they have given.
Okay.
You try to solve it. Okay, here there is a problem. What they have done now, these kind of things may confuse you, right? These kind of things may confuse you. Like, where is this differential equation coming from? A force on Q due to line elements at A and B. Hmm, again, cos theta is involved here. This will be your theta in this case. Exactly same question. Just draw a triangle and you'll get the answer, right? Do it yourself. This one.
Yes, sir.
Uh, right. You can do this thing. And exactly same question. Just see this thing. You have to find out this thing, omega is square, and then find out the time period like this. Exactly the same thing we have done. Right. Right? That is the thing.
Yes.
31 is done. Okay, the last question I told you, I'll explain that thing as well. That Lilton question, something which for expansion question, right? Expansion question. This question. The solution to this question is really tough. 26. This one is the solution. Okay. I don't think you understood anything of this problem, right? Did you get anything from this solution?
No, sir. I don't even know what's critical value.
Yeah. Uh, okay. In simple terms, I'll just try to explain this thing. Just see what is the question. Uh, in 1959, Littleton and Bondi suggested that the expansion of the universe could be explained if matter carried a net charge. Suppose that the universe is made up of hydrogen atoms with a number density n. Okay, here, what do you mean by number density?
I'm not sure.
Number of atoms per unit volume.
Okay.
Per unit volume. This is the thing, number density, which is maintained a constant. Let the charge on the proton is, okay, so EP is given to you as this much, where E is the electronic charge. Find the critical value of Y such that the expansion may start. Show that the velocity of expansion is proportional to the distance from the center. Mm, what it says this thing, when the expansion will take place, this universe is expanding. So currently the current explanation is this thing, that there are some dark energy which we haven't yet, we do not understand it yet, but there are some dark energy responsible for it. But these scientists try to explain in terms of the net charge in the universe. Like, let us say that every atom is not neutral. Like, atoms have a net charge. Atoms have a net charge means whole universe is made up of hydrogen atoms. Let us say that two hydrogen atoms or three hydrogen atoms. They will do what? They will try to stay away from each other. If this is the charge, they have negative charge. Just see this thing. That the charge on the proton is slightly negative. Okay, negative charge. Proton, they have given a negative charge to the proton. Okay, let the charge on the proton be EP minus 1 plus Y. So if Y is an extra amount of charge on the proton, right? Extra amount of charge on the proton, they should have given it positive. Okay, they have given it negative. Fine, no problem. So where, okay, in this case, just imagine that electron, what is the hydrogen atom? There is a proton at the center and there is an electron here, right? That is the thing. So in that case, EP is given to you as minus 1 plus YE. And electronic charge is given to you as simply plus E. So proton is being taken as negative charge and electron is being taken as positive charge. They did that, right? They assumed that electrons are positive and protons are negative. That would have been that would have been a very wise choice in the beginning. But they assumed that protons are negative and electrons are positive, and protons carry a little greater than the electronic charge. We know that it is definitely the same, right? It is digit by digit, every decimal place is exactly the same. That is why there is a perfect order in this universe. So let us just see this thing here. If they are just, see that they are all carrying a negative charge, all the hydrogen atoms carrying a negative, because EP is greater than this thing. If I say this, the magnitude of EP is greater than magnitude of E, clearly, right? That is the thing. So they will repel each other.
Yes, sir.
Every charge will experience the force in this direction, right? In this direction, they will try to stay away. So expansion, that is what they are referring to as expansion. This, if there is no other force in this universe, then obviously the resultant force will be in this direction. They will try to go as far away as possible because of the net Coulombic repulsive force, because they have the same charge, right? Identical charge. So they explain that this universe is expanding because the things, the charges, atoms are not neutral. Atoms have some charge. So they just imagine that let us say that this entire universe is just made up of hydrogen atoms, and hydrogen atoms are negatively charged. So find the critical value of Y such that the expansion may start. Expansion, when can the expansion start? Just see that they have masses also, right? They have masses also, and What is the universal law of gravitation? Any bodies having mass attract each other with some force. So there is attractive force between them also and repulsive force between them also, right? They are attracting each other also and repelling each other also. The critical value of y will be such that the repulsive force should be greater than the attractive force. That Coulombic repulsion must be able to overcome the gravitational attractive force. Then the universe will be expanding. You got anything what I said?
Yeah. Yes, sir.
Yeah, simple. You can just imagine that two charges. Let us say that they are hydrogen atoms. They are negative charges. Obviously, the net force will be what? Repulsive force. They are repelling each other. Let us say that F, F, they are repelling each other. But let us say that Fe, they are repelling each other, electronic force. And there is a gravitational force also. They are attracting each other also because they have mass also, right? But just see that Fe is much, much, much greater than Fg. Gravitational force is very, very weak, right? So electronic force will definitely overcome the gravitational force and therefore repulsion will persist and this universe will expand. Because gravitational force will not be strong enough. If I say that if this is 10 Newton, this is 0.00000 Newton, 0.1 Newton. Obviously, this much of force is not enough to counter 10 Newton of force. So 10 Newton of force will overcome the force, gravitational force, and the expansion will take place. And that is the thing. Let's see that what they have done here. Now you can understand. First thing, let the universe have a radius r. So they imagine that this universe is spherical. So you can imagine the universe to be spherical of radius r. Assume that the hydrogen atoms are uniformly distributed, and so uniformly distribution means what? Rho is constant. What is the unit of rho? Coulomb per meter cube. We have seen this thing in the first question. Coulomb per meter cube. Rho simply means Q by V. Assume that the hydrogen atoms are uniformly distributed. The charge on each hydrogen atom is this EH is equal to negative charge of proton plus positive charge of electron. So net charge is equal to minus YE. So the magnitude is simply YE, net charge on the hydrogen atom. YE is the magnitude of the charge. The mass of each hydrogen atom is MP. Expansion starts if the Coulombic repulsion on a hydrogen atom at R is larger than the gravitational attraction. That's what I was talking about, right? Simple. Let the electric field at R be E, then 4 pi R is they have used the Coulombic force, like Gauss law. Yeah. Did you understand where does this come from? I think you must be able to understand now this one. Where is that coming from?
Yes, sir.
Simply, this is this formula, right? E dot ds is equal to q enclosed by epsilon naught. Exactly that thing. And here q enclosed will be equal to what? Q enclosed will be simply equal to rho dV. Rho is a constant. So dV is equal to I have told you, right? Um, no, in this case, they have done this thing. Let's see. Number density is given, so we don't need to do that. Q enclosed will be volume multiplied by number density. Number of atoms per unit volume. So if I know the entire volume of the universe, if I multiply it with the entire volume of the universe, then we'll get the total number of hydrogen atoms. Okay, and if I multiply with the charge YE, I will get the total charge of the universe. Is that okay? Do you understand this thing? Volume
Okay.
multiplied by number density multiplied by charge. This will give you the total number of hydrogen atoms. Total number of hydrogen atoms. And one hydrogen atom has charge on one hydrogen atom. Charge on one H atom. Clear this thing?
Yeah.
So volume of the universe is equal to what? It is spherical, 4 by 3 pi r cube. Getting it? This is the thing. Multiplied by number density, multiplied by YE. That is what is given. So Q enclosed. Therefore, total flux will be equal to what? Q enclosed by epsilon naught. See this thing. 4 by 3 pi r cube n y e by epsilon naught. That is what it is given. And here, total surface area E is constant at R position. So E ds is equal to 4 pi r cube n y e divided by 3 epsilon naught. And this is E is equal to 4 pi r square into, they have taken field, gravitational field as gr. Okay, this E, no, electric field, no, sorry, what I'm taking, my mistake. So electric field is equal to this thing. From here you can get the electric field. I hope you got it right. 4 pi r cube n y e divided by 3 epsilon naught. This much you got it?
Yes, sir.
And then you calculate the gravitational force. You can apply Gauss law on this thing as well. Exactly same way. But in this case, you see that gravitational field is defined. Gravitational field is defined like this. It is exactly the same way. Gravitational field is simply defined as gr is equal to, gravitational field is equal to gravitational force divided by mass. And if I say this thing, limit m tends to 0, F divided by m. Exactly like charge, nothing else. Force per unit, and what is the unit of this? Newton per kg is the unit of gravitational field. Just like electric field is what? Limit q tends to 0, F by q, right? This is Newton per coulomb. So here the mass, instead of a charge, there is mass. Mass is the element, but one of the differences is that gravitational field is always attractive, while the electric field can be attractive and repulsive both, right? It can be in two directions. So gravitational field is always this thing. And if you just find out the formula for this thing, gr is equal to g m by r square will be the gravitational field. You don't need to do these things, these kind of complicated fields. So Vm, total mass of the universe, calculate the total mass of the universe divided by g r square. V r square, right? What is the total mass of the universe? M is the total mass of the universe. Total mass of the universe. How will you calculate this thing? Total mass of the universe. The hint is given here. Number density is given to you.
Yes.
Number density will be multiplied by the volume 4 by 3 pi r cube. This will give you total number of atoms. We have already seen this in volume multiplied by number density. Then multiplied by the mass of the proton. Isn't it? You will get this thing. Just put this value over here. You will get the answer. So ZR will be simply equal to Zn 4 by 3 pi r cube mp divided by r square. R square cancelled. This will be r, and that's what they have got here. Exactly same thing. Right?
Okay.
4 by 3, isn't it? 4 by 3 pi g mp and r, exactly the same. Nothing else. So gravitational field is done. Now the electric field is equal to what? It is simply F is equal to what? QE. Charge is equal to this much and field is equal to this much. So gravitational force will be this much. And this will be here, the field gravitational force will be, let us say that it is the repulsive force. This will be in this direction. So r cap direction is given to you in this direction. While the gravitational field here the force will be like, let us say this is electrical force, right? Electrical force, and this is gravitational force. This is equal to mp gr. Simple. This will be always towards the center. Fg Fe. So which will overcome? Fe is greater than this thing. So net force acting will be equal to this direction. They are in the opposite direction, right? They did this thing. And for that thing, this must be equal to zero vector. This can be zero if this entire term comes out to be zero. When this comes out to be zero, then these two terms, this and this term will be equal. And they did this thing at critical value. What is the critical value now? That will be the critical value at which the net force is equal to zero. Just see that. When will the force be repulsive? If they are equal, then that is the critical value, right? Beyond that point, the force will be repulsive. If the gravitational force is equal to the, like, critical point happens, like just see that critical point at critical point Fe is equal to Fg. Gravitational force will be equal to electrical force. That's it. Just equate these two things and you will get the answer. Yc is equal to this thing. How much you got from here? This is charge on one hydrogen atom. You understood this thing, how I calculated the gravitational field? See, where is it coming from? Gr is equal to what? Gravitational force divided by m, right? So total mass of the universe is equal to what? G capital M by R square divided by M cancelled. We are getting Gm by R square. That is how I got the formula for the gravitational field. Any point is not clear? It's very complex, I know that.
Yes.
Which part you're getting it? Okay, do revise these things. Okay, one more thing here. Now you will be able to understand this thing, right? Just see this thing. Net force is equal to this much, right? F is equal to this much. That is what they have used. That F is equal to simply what? F is equal to, this is F is equal to this much. And F can be written as what? MA, MA. And A can be written as what? D square R by dt square, dt2. That is what they have done this thing. So acceleration, if you solve this thing, just see this thing. R is common, R they take out. And this thing, this entire thing is written as alpha, alpha square R. So now you have a differential equation d2r by dt2 minus alpha square r is equal to 0. If you solve this thing, you will get this answer, the
Okay.
value for r. This is the differential equation solution. Obviously, you'll learn it in the 12th grade itself in mathematics, how to solve these things. But the general solution will be this thing. Now, for expansion, if you draw these graphs, one graph is something like this, and one graph is something like this. So as t is increasing, RT versus R. So obviously this is expansion. This represents expansion, right? This represents expansion. So this will not be the value. This will be the value. For expansion, this B should be 0. So R is this much. And now once you have got the value of R, then velocity will be simply equal to dr by dt. Just differentiate this thing and you'll get the answer as this much. This thing they have written wrong. This is actually dr by dt. That is the velocity and you'll get the answer. This is the answer. Then you can show this thing that velocity is directly proportional to r. Right?
Yes, sir.
Okay, you revise these things and let me know. I'll upload these notes, right? Try to understand these things and let me know if there is anything that is not clear, right? Although these kind of questions will never be asked in the board exam. So
Mm.
I would suggest that you should not waste too much of your energy on these things. Try to understand some of the things, it's okay, but do not spend too much of your energy on these kind of questions. There are so many things to be covered, right? Already. We have to cover a lot of things already. First, we'll cover the most important things. Then, for interest sake, you can do these kind of problems or for extra preparation,
Mm.
right? So next class, we'll start the chapter 2.
Yes, sir.
Okay. Okay then, bye.
So tomorrow we can continue with chapter 2.
Yes, tomorrow, right? Okay.
Yes, sir.
Okay then, bye.
Thank you, sir.